Good morning. We are going to finish up a little bit from 2.5, just a good refresher on the union, intersection, and compound inequalities. I'm going to share my screen for you. And this is where we were. We were talking about the OR situation, where we include the solution for all inequalities, and the AND solution, which is where we include only where the inequalities overlap. And there were a couple on this page, D and E, that I wanted to show you. So we want to look at, this is an OR situation, when X is greater than or equal to 1 or X is greater than 3. So if we were to draw the number line, here's 0, 1, 3, because 1 is, we're shading everything this way, or 1, because it's greater than or equal to 1. And then we're shading everything this way of 3. So it's essentially all real numbers. Similar to the one above. Letter E. Again, we're going to draw our number line. We again have greater than or equal to 1. Or greater than 3. So it's including everything greater than or equal to 1. All of the inequality for 3 is included in there. So we're going to use the greater than or equal to 1 because it's an OR, we're including both. Then we were expanding on the AND situation. Here are some great examples of the 4 situations that you would maybe want to put out and use on your test. And then let's solve this letter C down here. This is an AND situation. So I'm trying to solve for X. So I'm only doing operations that affect X. So I'm going to subtract 1 from all 3 parts. So we have 4 is less than 1/4. X is less than 8. And really, I should have multiplied through by 4. Following what we've been doing earlier. So if we cancel this out and we multiply through by 4, it'll be 4 times 5 less than 4 times 1/4 X plus 4 times 1 less than 4 times 9. So 20 is less than X because the 4's cancel, plus 4 is less than 36. So that eliminates our fractions. That's what we have been doing so far. And so to solve for X, I'm going to subtract 4. And we arrive at 16 is less than X is less than 32. And so on the number line, we've got 16, 32, 0 would be way down here. And they're both strictly less than, and so they both get an open parenthesis, and then we're shading in between. And so the interval is an open parenthesis at 16 up to 32 with an open parenthesis. Again, I started here, but I really should have multiplied through by the denominators to eliminate the fractions. And it actually made it an easier solution. So the last 3 that I would like to look at here. Okay, graph the solution sets for the following compound inequalities and write each solution set using interval notation. So we're solving for X. And this says 3x plus 2 is less than a -3 or greater than a +3. Okay. So we're going to subtract 2. And then divide by 3. So x is less than a negative 5/3. So I'm going to draw my number line here. So for this solution, x is strictly less than, so it's a positive parenthesis, and it's to the left. And then I'm going to solve for this x in this inequality. So we're going to subtract 2 as well, just like we did before, similar. 1. And then we're going to divide by 3. We're dividing by a positive, so we don't flip our sign. So x is greater than 1/3. So I'm going to draw 1/3 on my number line. Again, it's a strictly greater than, so it gets an open parentheses and I shade to the right. And so this is a union because it's an or, so I'm going to include both solutions. So we have a negative infinity up to a negative 5/3, open parentheses, with a union of 1/3 to a positive infinity. Again, it's a union because we had an or, and we had to solve them separately. So same expression on the left, we were just comparing to 2 different values, a negative 3 and 3. Let's look at the next one. The next one we have is the expression 7x minus 5 is less than or equal to a negative 2, or that same expression 7x minus 5 is greater than or equal to 2. So we're going to add 5 because we want to solve for x on both of these. So we get 7x is less than or equal to 3. And we can do this simultaneously because we're doing the same operations to solve for x on both inequalities. So we get 7x is greater than or equal to 7. I'll let you catch up. And then we're going to go ahead and divide by 7. So I'll show that here. So when we divide by 7, we get x is less than or equal to 3/7, which we will show on the number line. 3/7. And it's less than or equal to, so it gets a bracket. And we're going to shade to the left. And then on the second inequality, we're also going to divide by 7 to solve. And that leaves us with x is greater than or equal to 1. And 1 is over here on the number line. And it is a greater than or equal to, so again, we're going to include the 1, so it gets a bracket, and we're going to shade to the right. And again, because it's an or, we're including both solution sets. So my interval will be a negative infinity up to 3/7 union with 1 to a positive infinity. And a bracket on the 3/7 and a bracket on the 1. Excuse me there. So that should have been a bracket and a bracket because we're including, there's an equal and an equal. And the last one is a little bit bigger, a little bit more work for us to do here. So this time we have 3x minus 1 is greater than this expression 2x plus 4, or a new expression 5x minus 2 is greater than this, a new expression 3x plus 4. So there's 2 different inequalities being compared, so we're going to do them separate. It is an or, so we do include both solutions. So I want to get my x's to one side. That's my first step I need to do. I like to move mine to the left. Three x minus 2x leaves us with an x. Then I'm going to add 1 to both sides, and I have x is greater than 5. Get my number line ready. Okay, so looking at the other inequality here, again, I'm going to move my x's to the left by subtracting 3x. That leaves us with 2x minus 2 greater than 4. And then to solve for x, I'm going to start by adding 2. And then that leaves us with dividing by 2. And the 2's cancel, so we have x is greater than 3. So I'm going to mark both of my markings here. We've got 0, 3, and 5. And it's greater than both of them. And so really, it would include my 5 here, but because I'm also including my 3 here, the 3 covers everything. Because it's an or, I'm including both. So I'm going to go as far to the left as my 3. So my final interval is an open parenthesis at 3 because it's a strictly greater than up to a positive infinity. Take a minute to look at that. And catch me back for some more videos or reach out if you need help.